Slide 1. Chapter 10 is all about Professor Florzak's favorite subject, sampling. Sampling is actually a process of selecting representative units of a population for study in a research investigation and is usually found in the methods section of the article. An element can be an individual unit of a population, which may be a person, and if it's a person, it's then referred to as a subject, an event, or a behavior. The population is the entire set of individuals or elements who meet the sampling criteria. It is also known as the target population. And for an example, you might use all persons with type 2 diabetes. Now, the accessible population is the portion of the target population to which the researcher has reasonable access. And this might be all individuals in the Chicagoland area who have type 2 diabetes. The sample, which we're going to end up with, is obtained from the accessible population, and findings are generalized to the target population. Generalization, which is very important in this class, involves extending the findings from the sample under study to the larger population. The extent of the generalization is influenced by the quality of the study. In other words, was the study strong, the procedure controlled, the measurements valid and reliable, the statistics sound, and the sample representative of the population. And when we have done our work well, we have our sample. Now, over the next couple of slides, I want to talk about sampling criteria. Sampling criteria are characteristics essential for inclusion in the target population, such as someone being between the ages of 18 and 45. They have the ability to speak English. If you're interested as a researcher in persons who have gallbladder surgery, they would have to have gallbladder surgery. And maybe in our case of our diabetics, we want ones that are diagnosed with diabetes within the last month. Sampling criteria is also known as eligibility criteria. And remember, it is the list of characteristics essential for membership in the target population. In our case, we would want somebody who was diagnosed with type 2 diabetes. The sample is selected from the accessible population and meets the sampling criteria. Inclusion criteria are those characteristics that the subject or element must have to be part of the target population. Now we're going to look at a sampling criteria known as exclusion criteria. These are characteristics that cause exclusion from the target population, possibly a diagnosis of mental illness, someone less than 18 years of age, diagnosis of cognitive dysfunction, or unable to read or speak English. It is important, both inclusion and exclusion, to know these criteria because it increases the strength of the evidence and decreases those horrible extraneous variables that come in and muck up your study. Now, representativeness is very, very important for a research study. What it means is the sample, the accessible population, and the target population are alike in as many ways as possible. Representativeness needs to be evaluated in terms of the following: setting, characteristics of the subjects, and distribution of values on variables measured in the study. I'm going to talk a little bit about each of these. As far as the setting goes, individuals seeking care in a particular setting may be different from those who would seek care for the same problem in other settings, or those who choose self-care. The following factors are examples. Private hospitals usually exclude the poor. Since those hospitals exclude the poor, people whose hemoglobin A1Cs in a diabetic study might not be included, and it may affect your findings. Also, in some settings, the elderly and uneducated are not representative. And individuals who are cared for in research centers receive very different care from those in community hospitals. And finally, people in rural areas may respond differently to a health problem than those in urban settings. Gathering subjects across a variety of settings provides a more representative sample of the target population than limiting the study to a single setting. Characteristics of the subjects should also represent the population. That's the reason behind collecting demographic data on subjects in a study and doing descriptive statistics. You're going to find in a few minutes we're going to talk about different sampling methods, and when a convenient sampling method is chosen to collect your sample, the findings aren't going to be automatically generalizable. So if you as the nurse want to know if I can apply the findings from this particular study, you're going to have to go back and look at the demographic characteristics to see if it fits the patient population for whom you care. Measurement values are something we're going to take a look at, and these are numeric values obtained from the instruments used to collect information on the variables in the study, such as a questionnaire about health practices of people with type 2 diabetes. When all the numbers are collected off of your questionnaires and laid out together, they should look like a bell curve. This means that a large group should be in the middle and there should be smaller groups around the ends. For example, if we gathered information about the variable of being anxious before a test and had numbers 0 meaning no anxiety and 10 being extreme anxiety, there should be a large group in the middle who would be moderately anxious, a smaller group to the right who have little anxiety, and a small group to the left who are extremely anxious. The numbers should vary randomly, and if they do, when they are mapped out, it should look like a bell. This represents random variation and would represent a population that looks like the sample, the accessible, and the target population. Now, random variation. That is the expected difference in values that occurs when different subjects from the same sample are examined. The difference is random because some values will be higher and others lower than the average population values. As a caveat, as the sample size increases, random variation decreases, improving representativeness, which is what we want. We want to look at something called systematic variation or bias. This is the consequence of selecting subjects whose measurement values differ in some specific way from those of the target population. These values do not vary randomly around the population mean. For example, in our study with people with type 2 diabetes, the researcher wanted to have a really good showing for the blue suit. So he would go down to Lower Wacker and pick those people to show his hemoglobin A1C before and after because he did get a big bang for his buck. But this doesn't mean that it's representative of the entire population of people with type 2 diabetes. In this instance, when you laid the numbers out on a piece of paper, the hump in the middle would be skewed to the right or to the left, meaning that you don't have a representative population. Random sampling. Random sampling means that each individual in the population should have an opportunity to be selected for the sample. The purpose of random sampling, and for Professor Florzak it is random selection, is to increase the extent to which the sample is representative of the target population. Doing it means there is less chance for systematic bias to occur. Without random sampling strategies, the researcher could consciously or even unconsciously choose people who would tend to have conditions or behaviors that were consistent with the study hypothesis, or they could exclude people who did not support the hypothesis. By using random sampling, the researcher leaves the selection to chance and increases the validity of the study. Well, how in the world do we get this representative sample? Well, one of the first things you have to do is create a sampling frame. That is a listing of every member of the population using the sampling criteria to define membership in that population, and then the subjects are selected from the sampling frame. For example, on the slide, we got a hold of, somehow, every person in the Chicagoland area with type 2 diabetes. What we would do is list all of their names and then put a number next to it. Then we're going to use a table of random numbers from which to pick our sample. And I'll go into this in a little bit more detail in the next couple slides. Now, there are two types of sampling plans that can be used to get a sample for your study. One are probability sampling plans, which are the ones that are preferred. The second one is non-probability sampling plans, and you're going to find that most studies use non-probability sampling plans, much to my chagrin. Now, the probability sampling plans include simple random sampling, stratified random sampling, cluster sampling, and systematic sampling. Simple random sampling is the most basic and is accomplished by using that sampling frame that we just discussed. What happens is the researcher closes her eyes and places her finger on a number in that table of random numbers, moves up and moves down, or across, selecting numbers from that table, and with each number refers to the list for the individual. Then they become part of the sample. This is done until the sample number is complete. Another way to do it is to put the names in a hat and draw one at a time until we've collected our sample. The second way is stratified random sampling. This is used when the researcher knows some of the variables of the population are critical for achieving representativeness. For example, age. If we needed 50 people for our sample and wanted equal representation from the following age groups, 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69, we would divide our list of these 500 people by age, create a table of random numbers for 100, and randomly pick 10 from each group. Now we're going to notice there's a distinct difference between this and quota sampling, which we're going to talk about in a minute. Cluster sampling is kind of a drill-down strategy. In cluster sampling, you would have a sampling frame of all the states in the United States, all the cities, all the institutions and all the organizations in which the subjects to be included reside. The states are randomly selected. The cities in the randomly selected states are then randomly selected. The institutions in the randomly selected cities from the randomly selected states are randomly selected. Nursing units from the randomly selected institution, cities, and states are then randomly selected. And finally, patients from the unit can be used or even randomly selected. I have a few problems with this, but theorists say that this is a way of getting a probability sample. So I'll have to believe them. The last method is systematic sampling. This is conducted when there is an ordered list of all members of the population. The process includes picking every kth person, meaning maybe every 10th person on the list. The population size is divided by the sample size, giving it the gap between the individuals on the list. Using our list of 500 people, if we wanted a sample size of 100, we would divide 500 by 100, and every fifth name would be chosen. What makes it a randomly selected method is that the researcher takes her finger and puts it on the list blindly, and that's where the starting point is to choose your sample. Now there are the non-probability sampling strategies. And for quantitative research, that is convenience or accidental sampling and quota sampling. And you're going to find that in most of the articles that you read, you have convenience sampling. In non-probability sampling, not every member of the population has an opportunity for selection in the sample. This decreases the representativeness of the study. Convenience sampling is considered a very poor choice since there is little opportunity for controlling bias. Subjects are included just because they were there. An example would be if you ever go out into the mall and are doing some shopping and somebody just wanders up to you and said, "Do you want to do this survey?" That is an example of convenience sampling. It is used, however, because 1, it's very inexpensive, 2, it is accessible, and 3, it is less time-consuming. The only problem is there is a huge risk for bias in this convenient sampling method. Quota sampling looks kind of like our stratified random sampling, but there's no random selection involved, which means that, if you can visualize this, you as the researcher are standing outside of a physician's office. As his or her patients come in for the day, you ask them their age, and you put them in a column that says age 20 to 29 or 30 to 39, and you fill those columns up. But it is not the same as making our table of random numbers and then choosing them randomly to fill up those slots in the different categories. Now, there are a couple of other non-probability strategies. One is matching. That's where you be looking at 2 different groups of people and trying to compare them on a certain characteristics. And you might want to match them on age, their sex, how much money they make, etc. But this is a very difficult thing to do and can even limit your generalizability by doing it that way. Networking is also called snowballing, and that's where you get somebody to participate in your study, and then you ask that person whether they know somebody who may be interested in participating in your study. And that method, too, does not decrease the amount of bias in your sampling methods. Well, we've looked at the selection of the sample. Now we need to know how many subjects are required. This is accomplished through a power analysis. Power is the capacity of the study to detect differences or relationships that actually exist in a population. The minimum acceptable level of power for a study is 0.8. This results in a 20% chance of a type 2 error. And we're going to talk all about this when we do our statistics lectures. But a type 2 error is that the researcher did not find a difference even though one exists. You need to know 3 things to perform a power analysis. One is the level of significance, for example, 0.05 or 0.01, the estimated sample size, and the effect size. The effect size is how much of a difference is there between groups when looking at a specific phenomena. It is determined using formulas and information from previous studies. If an effect size is large, you only need a small sample. If the effect size is small, you're going to need a large sample. So, you need to know the level of significance, the estimated sample size, and the effect size to do a power analysis to determine how many people do I have to randomly choose to be in my study. Just as a rule of thumb, descriptive and correlational studies often require very large samples because multiple variables are usually studied and statistical analysis are computed on subgroups, and bias is a real concern. Quasi and experimental studies require smaller sample sizes because the control is stronger. As the number of variable studies increases, the sample size should also increase. And as the ability of the instrument to detect the phenomenon increases, the sample size may decrease. And finally, as the power of the statistical test increases, the sample size may decrease. The only thing I really want you to remember from this slide is that the researchers in the article should talk about doing a power analysis to determine the number of subjects that they needed. Now, all those different sampling techniques that we've just talked about all belong to quantitative research. Qualitative research is a different animal. Qualitative research is not done to generalize findings to a population. Therefore, they can use non-probability sampling. And in qualitative research, it is called purposive sampling or network sampling. Purposive sampling involves the researcher's judgment on selection of certain subjects to include in the study. For example, I had a colleague who was looking at children with spinal bifida. So she knew that she had to go and find those children with spinal bifida, and she chose them from her physician's office. This is an acceptable means because, remember, qualitative research is not generalizing findings. It's only used to increase your understanding of the person's, let us say, predicament that they're in. Network sampling is using the subjects as a means of finding other subjects with similar characteristics. For example, my colleague may have said to one parent who had a child with spinal bifida, "Do you know another parent with a child who has spinal bifida who might be interested in my study?" So that's an example of network sampling. Well, if you remember, to determine sample size in quantitative studies, we needed to do a power analysis. Well, sample size in qualitative research is completed when there is saturation. Saturation means finding the same statements over and over and over again. It depends on the scope of the study, the nature of the topic, the quality of the data, and the study design. Generally, if the scope of the study is broad, more subjects will be needed to reach saturation. If the topic is clear and easily discussed, then fewer subjects will be needed. If the quality of the data is good, then fewer subjects will be needed. And if the study design includes numerous interviews, then fewer subjects will be needed. 3. Well, what size is right? The sample size should be determined before the study is conducted, except in certain qualitative designs and pilot studies. And the general rule of thumb is always to use the largest sample size possible. And just to repeat, sample size should be calculated with a power analysis for quantitative studies. Describing the sample. When you describe the sample, you should use the demographic characteristics. You should also have inclusion and exclusion criteria. The sampling strategy should be discussed, and you should talk about the screening, recruitment, and enrollment protocol. And I'm going to tell you, in reality, the demographic characteristics and the inclusion and exclusion criteria are usually within the article, but they usually don't talk about the sampling strategy. You kind of got to figure that out. And they don't talk about how they screened, recruited, or enrolled, mostly because in these studies there is a word limit, and the researcher wants to tell you about the most important findings of the study, not some of the things that are not so important. The description of the sample should also include the sample size and the calculation used to arrive at the sample size and problems encountered in recruiting or enrolling appropriate number of subjects. And again, the researcher will talk about the sample size. They may talk about the calculations, but they hardly will ever talk about recruiting or enrolling the appropriate number of subjects. Now, there are sampling threats to our internal validity, and remember, our internal validity, do all the pieces of the puzzle fit together? Is there control? There can be a selection effect bias because of the subjects self-selecting or researcher bias in selecting the sample. For example, if you go to your internist's office and there is a sign on the wall up there saying, we need people for a study in such and such drug study for depression, the people who choose to go and do that study are probably going to have different characteristics than those in the general population who have depression. Another threat is attrition or mortality, which is loss of subjects from the study. If the subjects who remain in the study are different from those who drop out, the results can be affected. 7. And then there's the sampling threat to external validity. And remember, external validity was the ability to generalize to other populations or settings. Now, in most of the articles that you are going to be reviewing or reading, probably for the rest of this program and maybe the rest of your career, you're going to find that most of the sampling strategies are convenience sampling. And when you do that, you cannot take the findings and just generalize them to the population. The findings in studies that use convenient sampling can only be applied to the sample or individuals that look like the sample. Thus, you as the nurse, if you're working on a unit and it specializes in care of patients with diabetes, and you come across a really good study that has really good interventions, that you think may be useful. You're going to have to go to those demographic characteristics and inclusion and exclusion criteria and look at them very carefully to see if your patients match those characteristics before you can use the findings of the study. Now, that's the end of this lecture on sampling. I want you to go look at the YouTube clips that I have put up for this sampling lecture in your weekly information folder. And I will see you in class.